Okay, now that we learned the basics of how recursive function works and also how similar or different from and to the loops, let's think about how to design or how to write a recursive function. So it's kind of similar to writing a loop. Well, what do you start with writing a loop? You have to think about like when to stop, right? So what's most important is when to stop the recursion to. So identify when to stop, base case, okay? So here, what is the base case in sum function? This is the base case. The sum function is basically decrement each argument one by one, and eventually it reaches one, and then there's no, that's the time when you don't make another calls anymore. Base case. That's one. And then now, it was kind of important in the loop to think about the index variable. Something similar. So something similar to the index variable in the loop is basically the input to the recursive function. So the role of the input is kind of important. So you have to understand like how to set up the role of the input. Okay, similar to the role, similar to loop index. Okay, usually you increment the loop index, but usually base case is small, fixed value. So we in recursion, we usually the input gets decrement, gets smaller and smaller. Okay. And we have to think about the role of the output too. So what it returns is basically something similar to total. In loop, okay? That means what? This is accumulated value in a sense. So here, sum n minus 1 is really what? Accumulated already when it returns. Remember, base case is the first time when the return phase starts, right? And then starting 1, all these things accumulated when the return phase reaches like returning n minus 1. Okay? Okay, so you have to understand the role of the output. Okay? And also, that means what? If you understand the role of the output, you have to think about how to use the output. Now, the output is important in terms of how to use the output, and also is important how to return, the function itself, right? So remember, this is sum n, right? The function is what? We have to return the sum of all the things, 1 to n. Now, well, if you understand what this sum n minus 1 means, it's easy to, output the right value. What's the right value? We'll add n, one more, okay? How to use the return value from the call to construct the real actual output of this function, something like that. Okay, so that's kind of like some things you need to think about. One more thing you need to note is how do you make sure the correctness? In a sense, we have two cases. So as long as you can make sure the recursive case and the base case are both correct, then you can actually guarantee the sum function returns correct value for all the values. Okay. Why is it that? Let's think about sum 1, sum 3, right? So if sum 2 is right, is correct, meaning sum2 is basically returning 1 plus 2, right? Then sum3 must be right, because that's basically recursive case, the chain case, right? Now, what about sum2? Sum2. Similarly, we can argue if someone is correct, right? Sum2 is correct. Again, this is due to recursive. And then it boils down to sum1. Well, it's correct, returns 1, the base case. So what I'm saying is that some kind of similar argument can be done for whatever the value is. What about sum back? Sum 100. Sum 100 argues what? Well, if sum 99 is correct, my output is correct. And sum 99 says, if sum 98 is correct, my output is correct. It goes all the down to the base case, and the base case says, I'm correct. So this is like chain of correction, chain of, correctness argument. It goes all the way to 100 or 1,000. So in a sense, this is mathematical induction. It's basically proof by induction. Okay? So now, let's think about one more example. So let's think about this program. So basically, it prints out the triangle in reverse triangle. Okay, what do you think about it? So it will be basically calling triangle on one number. Okay, so that means what? The recursion is what? This. So each iteration goes, let's say n is 10, then it'll call 9 and it'll call 8 up to, let's say 0 or 1. So base case will be 1, let's say. 1 is what? Well, printing out only 1 star, but no more recursive call. You stop the call, okay? And then what? For the recursive case, what do? What is the job? What is the adding job? The job of the function is really tiny, but like you have to print out each line, okay? And then delegate the rest of the job to the n-1 triangle. Okay, so if you want to draw the whole triangle, basically just draw one line and then delegate the rest of it to the other function. Okay, and then go down, 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 down up to the base case, drawing 1. Does it make sense? So applying that kind of idea, let's think about it. So here, standard IO, and then let me just, that's the basically prototype, right? And then what do you do? Printf, let's say enter n. And then you got a n, scanf. So %d is the right one, give the address. Now you have n. What you do is basically call triangle. Okay, remember the design. Design is what? We have to think about the base case, right? So void triangle. Base case is what? N is 1. What do? You only print 1 star, but no more try-call. So that means what? If n is 1, what do? 1 star, and then done. And then what? If other case, what do you have to do? Your job is basically what? N stars. Take care of this one line, and then the rest of the job, call n-1, something like that. Okay. So I'll create some function star. Okay. Let's say n stars. So basically this is printing n stars. Printf So n times, and then yeah, you have to do the new line. Okay. Now, how do you do the base case? 1 star. Oh no, 1 star. Star 1. Okay. And then done. Okay. And then here, what? N stars. N stars. And then, well, let the other function, the try function with n minus 1 will take care of the rest. Okay. So this is base case. This is recursive case. Okay. Let's see if it works. Yeah, it works. Okay.